All right, so section 4.4. I talked to Ms. Carver. She said you guys did this before the break, and you should have seen a video or two from her. So I'm going to go through this relatively quickly. If you guys have questions, again, stop me. You're going to have a quiz. Right here at the top here, you have a quiz on Friday, which is February 2nd, and it's over sections 4.4 and 4.5. So we're going to do 4.4 today and then 4.5 the next couple days, and then we'll get moving on that. All right, factoring polynomials, guys. I like to do factoring. Sometimes it's a little different than other ways that you have seen things, but I like to think of it as a checklist that we have to go through. All right, a polynomial is just an equation that has a bunch of different terms. Terms are separated by plus and minus signs. So if they say to factor completely, that means you want everything broken down as much as possible. So I like to think of factoring like this. The first thing we're going to look for, that's a bad color choice, is the GCF. What do I mean by GCF? Greatest common factor. Good. What do they all have in common if they do? A letter, number, same thing. The second thing we're going to look for is it a special product? You guys remember you talked about special products? Like difference of squares or perfect cubes. Let's see if I can draw a cube. Something like that. Difference of squares, perfect cubes. We'll talk about that in a little bit. And then 3, we like to say, is it a trinomial? What's a trinomial? 3 terms. If it's a trinomial, we want to try to break it down into 2 binomials. And then the last thing we're going to say is, okay, if there's 4 terms, what do we do if there's 4 terms? Anybody know? Anybody remember? Grouping. Okay, we may not have gone over that yet. No big deal. But we always want to start with that first step of, is there a GCF? Because if there's a greatest common factor, you need to take that out before you start trying to break things down. So we always look for a GCF, then we'll talk about special products, special patterns if we have anything. And then if it's a trinomial, we'll break it down, or if there's 4 terms for grouping. All right, let's go here. First thing we're going to always ask ourselves, is there a what? A GCF, greatest common factor. Look at A. Is there a letter or a number that all 3 of these have in common? An X, right? So if I factor out the X, guys, we pull it out in front. It doesn't go away. If you don't write it out in front, then you haven't fully factored. You've taken something out, and it's not being represented anymore. So think about this. We're going to divide each one of these factors by X. So what am I left with my first term? X cubed divided by X is what? X squared. Perfect. 4X squared divided by X is minus 4X. Perfect. And then what? Minus 5. Awesome. So we've taken out that GCF. I'm going to leave it out in front. And now I say, okay, I have a trinomial. When we have a trinomial, we try to break it down into 2 what? 2 binomials. Good. So we're going to take my A term, which is 1, the number in front of X squared, and your C term. And you're going to multiply them. 1 times negative 5. All right, that's our special number we're trying to get. We're trying to find 2 factors of negative 5 that multiply to give me negative 5, but add to give me a negative 4. What are my choices? 5 and 1. Okay, I agree. So X is going to go in the front of here. Now, I need it to be a negative 4 when I add them together. So what needs to be negative, the 5 or the 1? The 5. Good. So plus 1 minus 5. Can we check? When we get down here, can we check? Yes, absolutely. You could say, well, 1 times negative 5 is negative 5. Good, that's what we wanted. And then negative 5 plus 1 is negative 4. That's what we wanted. So right here, we are factored completely. In a little bit, in the next couple sections, we're going to say, okay, well, let's go ahead and let's get this as factored completely as we can and then figure out what X equals. The one extra step would just be setting everything equal to what number? 0 and solving. Good. And a little tidbit that's really helpful. When you guys start any of these problems, the highest exponent is how many zeros or answers you should have. So if there's X to the third, then you should have 3 answers, which we do. There's 1, 2, and 3. All right, so let's look at B. First thing we look for is A, GCF, right? Is there a letter and or number that goes into both of these terms? 3 The whole number 3 and y to the third. So look, we're going to divide out 3y cubed. Did I take it out? Do I completely remove it? No, I just stick it out here out in front. So 3y cubed. What's 3 divided by 3? 1, good. And then y to the fifth divided by y cubed is y squared. Minus, what's 48 divided by 3? 16, good. And then my cubes cancel. Are we completely factored at this point? All right, well, let's talk about it. We took out the GCF. That was our first step. The second step said, is this a special product? Is this something special? What does the word difference mean? Subtraction. And what's a perfect square? Anybody articulate what a perfect square is?
When something can times itself.
Correct. A number or letter times itself. Can I take y squared and break it down to what? Y and y. What times what is going to give me 16? 4 and 4. Is there a minus sign in between these two perfect squares? Yes. So that means you can break this down a little more. You still have your 3y cubed out in front. And then I have 2 parentheses that look exactly the same with their terms. A y and a 4. But if it's the difference of perfect squares, do I have the same signs in between or do I have different ones? Different. 1 plus and 1 minus. It doesn't matter where you put them. Just 1 plus, 1 minus. Because when you were to, if you were to FOIL those back together, the middle term would cancel out. The difference of perfect squares has to be a minus sign in the middle, and both the terms have to be perfect squares. But there's your completely factored. All right, let's move on here. Oh, I don't like Z's. They always turn into different looking letters, but we'll go with it. What's the first question you ask yourself? GCF. Is there a number that goes into all 3 of these terms? 5. Okay, I agree. So I'm going to put a 5 underneath. Is there a letter that they all have in common? Z. How many Z's? 2. So squared. Good. So I have my 5z squared out in front. And this leaves me with z squared plus, what's 30 divided by 5? 6, good. And then what's 45 divided by 5? Plus 9. Okay, good. All right, we have to completely, fully factor, so we might be able to break this down a little more. Let's try. Do I have 2 terms? So this could be like the difference of perfect squares or anything like that? No. I have 3 terms. If I have 3 terms, what do I try to break this trinomial into? 2 binomials. What would go in the front of each parenthesis? A z. Okay, we're going to take a, your first term in front of z squared times c, the last one. 1 times 9. That's my magic number. What are the factors of 9 that could multiply to give me a positive 9? But when I add them together, I get 6. 3 and perfect. Good. There you go. I think you guys actually did watch the videos. Nice. Makes life easier. All right, factor completely. What's the first step? We're going to go through this a little quicker because these are very similar. What's the first step we always ask? GCF. Is there one? What? X. We're going to take that X out. Remember, if it helps you to stick it underneath here to remember to divide everything by it, perfect. So I'm left with x squared minus 7x plus 10. Yeah? Agreed? Okay, so I have a trinomial. Let's try to break it down into 2 binomials. We're going to multiply our a times c. Are there factors of 10 that when I multiply them, I get a positive 10, but when I add them together, I get a negative 7? What kind of 5? What kind of 2? Minus 5 and minus 2. Perfect. Because a negative plus a negative is going to give me another negative. But a negative times a negative is going to give me a positive. Good job, guys. Next up. We have anything in common? 3 and how many n's? N to the 5th. Very good. So this leaves me with n squared minus 25. If you guys can see that, you don't have to write the 3n to the 5th underneath both. That's fine. If you want to write it so you can see it better, that's fine as well. So am I left here with a trinomial that I can break down into 2 binomials? No. So is there anything else I can do here? Is this the difference of perfect squares? All right, what times what will give me n squared? N and n. What times what's going to give me 25? 5 and 5. Is there a minus sign in between these two? Perfect. Then this is the difference of perfect squares. So each parenthesis has an n in the front, a 5 in the back. And what are my signs in the middle? Plus and minus. Yep. Perfect. Same thing. What do we have in common here? am to the third. Perfect. God bless you. So you're left with m squared minus, what's 16 divided by 8? 2. Good. 2m plus what? 1. Ooh. I wonder if this one will work. Here's my a term. 1. I'm going to multiply a times c. 1 times 1. All right. My special number is 1 that I'm trying to get. Are there factors of 1 that could multiply to give me a positive 1, but add to give me a negative 2? 1 and 1? What kind of ones? Negative, negative. Very good. What's a negative 1 times a negative 1? Positive 1. What's a negative 1 plus a negative 1? Negative 2. Good, guys. Oh, it's hot in here. All right, special cubes, the pattern. This is not the easiest thing in the world to memorize. It is very helpful if you do memorize it. But a perfect cube is when you multiply the same number times itself 3 times. That's a perfect cube. So if you have 2 perfect cubes that you're adding, this is the pattern. The first parenthesis is the a term plus the b term. Then the second parenthesis, you say a squared minus ab plus b squared. Now look at the difference here, guys. When you have 2 perfect cubes and you're subtracting them, again, a now minus b, which makes sense because you're subtracting them, right? That makes sense that that goes there. That makes sense that that goes there. But in the formula for the second parenthesis, notice it's a plus sign here. That's where you guys are going to make mistakes. If you're adding the 2 cubes together, the first parenthesis has a plus, and then it's a minus, that next one. If you're subtracting them, the first parenthesis has a minus, but then it's a plus on the second one. It might be helpful to screenshot that and put it next to all of these questions that we do to kind of remind yourself the pattern so you get a habit of doing it. If you're going to completely factor, there's a bunch of different ways you can do this. I don't know if Ms. Carver is taught like to figure out what the perfect cube is to help you identify your A and your B. Meaning, I'm going to look here and say, are these 2 perfect cubes? Well, what times itself 3 times gives me x cubed? X. Okay, so my A value is x. What times my itself 3 times gives me 125? Okay, so my B value is 5. So you guys have determined these are both perfect cubes. So what are we doing to these? Are we subtracting them or adding them? Subtracting them. So when you break this down, your first parenthesis is just your A term minus your B term. That's it. And then your second parenthesis is your A term squared. So x squared. What's the thing that's kind of tricky? What goes in the middle here? Plus. Good. A times B, which is 5x. And then plus what? 25. Why is that last term in both of the patterns? Why is it plus? What happens when you square a number, whether it's positive or negative? It becomes positive. That's why that's always going to be a plus sign. All right, so let's look at B. B's a little harder. I'm going to use an X here just because I don't like using S's. So I have 16x to the 5th plus 54x squared. What's the first thing we should always look for when we're factoring? GCF. Because right now, nothing here is a perfect cube. So some of you might be like, oh, there's nothing. But I see right away that they have x's in common. They probably have a number in common. So what number and or letter can I factor out of both of these? 8 what? 8x squared. Okay, so 8x squared. What's 54 divided by 8? Is it 8? No? What's 8 times 7? 56? Okay. That's always a tricky one. No worries. Let's think again. That's all right. We're just we're catching stuff. It's not 8. What is it? Okay, let's try 4. Bad color choices here. So if I take out a 4x squared, what is 16 divided by 4? 4. And I'm left with what? X cubed. Okay, plus what's 54 divided by 4? Say it again. 54 divided by 4. What's 54 divided by, so 4 goes in here once, right? You guys agree? So I bring this down. Does 4 go into 54? No. Uh-oh. 16? What's 54 divided by 16? Okay, divided by 2. Look, we said 16. Guys, you're going to have to do this because you're not going to have calculators. So that's why I'm having you kind of work through it with me, because just writing everything down like I do it doesn't help much. If we say 16 times 3, it gives me 48, right? So it's not 16. What's the smallest number we could divide? Okay, let's try 2. Let's just see what happens here. If I take out 2x squared, what's 16 divided by 2? 8. X cubed, good. And then plus, what's 54 divided by 2? 27? Yes? Okay, now I'm glad, guys, I went through that way purposefully. Because it's not always going to be the most apparent thing. It's not always just going to jump out at you. So when all else fails, start with a small number and see if you can work up from there. It's really important that we know our multiplication tables. 54 and 56 gets us a lot. Now, when I work this out, did I discover perfect cubes? I still have my 2x squared out here. Is 8x cubed a perfect cube? What number times itself 3 times gives me 8? 2. And what number times what letter times itself 3 times gives me x cubed? X, okay. And then my b term, what number times itself 3 times gives me 27? 3. So you still have your 2x squared out in front here. And what are we doing to these two perfect cubes? We're adding them, so then I'm going to have 2x plus 3 inside here. And then watch how I write this, guys. My first term is 2x, and it's squared, correct? What goes next? Minus 2x times 3, correct? Plus my last term, which is b, squared. So let's simplify this a little bit. I still have my 2x squared out in front here. I have my 2x plus 3 here. When I have a 2 outside of this parenthesis, where does that 2 go? Does it go to just the x? No, it goes to the number and it goes to the letter. So what is 2x quantity squared? 4x squared. Good. Simplify this. It's minus what? Minus 6x. And then what's 3 squared? Plus 9. Gotta be careful with that. That one's a little tricky. Little tricky, but good job. All right, scooting along. Factor by grouping. When do we group? 4 terms. When you have 4 terms, you always look for the GCF first, just to make things a little smaller, but then you have to factor by grouping. All right, some people teach this different ways. I'm going to show you how I do it. If you like the way Ms. Carver does it or something better, that's why I do it that way. If you're going to factor completely, what is the first thing we look for? GCF. Is there one that I can take out of all 4? Yes or no? No. So I'm going to rewrite this with x's just because my z's are crazy. 5x cubed, x minus 20. All right, factor by grouping means you keep the first 2 together and the second 2 together. Watch how I do this. I have my first 2. Look how I kept that negative sign with the 4. Everybody see that? Whatever sign is in front of that third term has to stay with it. So now I look at my first set of parentheses. What can I take out of both x cubed and 5x squared? X squared. So I'm going to take out that x squared, and what am I left with? X plus 5. Now the whole reason we group is to create a GCF that is hidden inside here that I don't see. So we're going to keep going. Guys, what do you, I don't know if you've talked about this before, but when you lead with a negative here, do we like to leave negatives inside parentheses when we're factoring? No. We want to get that negative out. My second parenthesis, I want it to be the same as my first one that I just took out. So what can I take out of -4 and a -20? I can take out a -4, because watch what happens here. If I divide this by -4 and this by -4, a negative divided by a negative is a positive. Good. And then a negative divided by a negative is a positive. What did I just uncover here? Do you see two parentheses that are exactly the same? Yes or no? That's your new GCF that you just created. So now we're going to write that new GCF one time. We're going to write it out here one time. Now it's gone. And then what do I do with my leftovers? They get their own parenthesis. Good. And now we're really proud of ourselves. We're like, man, we just did a lot of factoring. Do you notice anything else? Where is the difference of squares? Good. X squared. Whenever you have two terms, one of them is squared, there's a minus sign, chances are it's going to be difference of squares. So I could really write this as x plus 5, and then what are these two parentheses? X plus 2 and x minus 2. Great. Good job. Very good job. All right, scooting along, scooting along. Now, you can look at this a bunch of different ways. This says factoring polynomials in quadratic form. All right, what that means, I have 6x to the 4th minus 81. If we're in quadratic form, right here, I don't have a b term. I can't say, oh, okay, I'm going to just say what times what gives me 81 and that sort of thing, and then figure out the middle. But I can do this and say the first thing we always look for is a GCF. Is there a letter or a number that goes into both of these? No. Shoot. Now what? What do you notice about 16, x to the 4th, and 81? Are they all perfect squares? Yeah, they are. What times what is 16? 4 and 4. What times what is x to the 4th? X squared, good. And what times what is 81? 9 and 9. All right, now what do we do with that? Okay, I'm going to put this in two parentheses. My first term in the parenthesis is going to be 4x squared. And my second term in each parenthesis is going to be what? 9. What are my signs? Negative and positive. Does it matter where I put them? No. So now we're like, okay, cool. I have this factored. I still have stuff that's squared. So you have to look and say, wait a second, is this a special product? Is this the difference of perfect squares? Is the first parenthesis a difference of perfect squares? The first one is? Is it the difference? It's not the difference because it's a plus sign. You can't break this one down anymore. This is just going to stay 4x squared plus 9. Because, and we'll learn this later, when you go to solve it, the numbers become imaginary, your solutions. But the second parenthesis has perfect squares. What times what is 4? 2 and 2. What times what is x squared? X and x. What times what is 9? Perfect. Is there a minus sign in the middle? Yes. So that means I can break this one down. What's the term that goes in the front of each parenthesis? 2x. Okay. And what's going to go at the back of each parenthesis? 3's. Good. And then what are my signs? Plus and minus. Notice, guys, in the blue here, those are exactly the same, but what is the difference? One of them has a plus sign, one of them has a minus. If they're perfect squares and there's a minus sign in between, you can break it down. If they're perfect squares and it's a plus sign, you cannot. So just be careful with that. All right, let's look at B. Again, I'm going to rewrite it with x's because so I have 3x to the 8th plus 15x to the 5th plus 18x squared. Look for a GCF first. What do they all have in common? A 3, agreed. And what else? X squared. Okay, so if it helps you to write the 3x squared underneath here, you do the mental math a little easier, that's fine. What's 3x to the 8th divided by 3x squared? X to the 6th, okay. What is 15 divided by 3? So plus 5. X to the 3rd, okay. And then what? What's 18 divided by 3? 6. What? Just like that? Okay. Can I do anything else? Okay. If we split them up into two binomials, what would go in the front of each binomial? I like your thinking, but what would go in the front of each binomial? Well, you have your 3x squared here. Okay, so what would you put here? X to the what? What times what's going to give you x to the 6th? Well, think about this, guys. If I put a 3 here and a 3 here, are you guys with me? Let's keep working. Come on, let's keep go along this train of thought. I want you guys to follow because you're going to have to do this on your own. Okay, so if I say 1 times 6 here, what are the factors of 6 that multiply to give me 6 but add to give me 5? 3 and 2? Okay. How come 6 and, I like your thinking, but how come 6 and 1 won't work? Because the 5 is positive and so is the 6. So it's two factors positive that multiply to give me 6 but add to give me 5. So, okay, we're going to go with plus 3 and plus 2. Are you guys 100% sure that this works? No. So should we just go, I hope so? No. If you get to a question on a quiz or a test and you're like, I'm not 100% sure, how could we go back and check to see if we factored this correctly? Let's FOIL it. Let's keep my 3x squared out here, and let's just FOIL this to see if this does work, because maybe it doesn't. And maybe we just stop right here. Yeah, sure. So what is x cubed times x cubed? What happens when you multiply bases that are the same? You do what to the exponents? We add them. Okay, so this gives me x to the 6th. So then I have x cubed times 2 is plus 2x cubed, right? Then I have 3 times x cubed is plus 3x cubed. And then I have 3 times 2 is what? 6. So I have 3x squared out here, x to the 6th plus, when I combine here, I have 5x cubed plus 6. So was that correct the way we factored it? Is this the same as this? Yeah, so you're good. But if you guys get to a point where you're like, oh, I'm not 100% sure if I did that right, take a second to just multiply back. And then you're like, oh, I did do it right. Or if it doesn't work, if the signs aren't the same, then you could say, okay, I messed up. I need to go back. But you can always check. All right. What time does this bell ring? All right, we got time. Hold on. Okay, here's like a hodgepodge of what we've done. So let's look at number 4. Number 4 here says a cubed plus 27. What's the first thing we look for? If there's a GCF. Is there a letter and or number that these two things have in common? No. All right, so I have two terms. Before I just say I can't do anything, is this special? Is this the difference of perfect squares? No. Is this the difference or sum of difference of perfect cubes? Yes. What letter times itself 3 times gives you a cubed? A, good. What letter or number times itself 3 times gives you 27? 3. So let's think about our pattern. We're adding them together, right? So this is a plus 3 at the beginning. Now it's a squared. So I have a squared. Then what? Minus 3a, perfect, plus what? 9. Great. Good, good, good. All right, let's go 5. 5, we have 6x to the 5th minus 750x squared. What do they have in common? X squared, good. Now some of you are like, I don't know if 6 goes into 750. Some of you will pull out your iPhone and do it real fast. But are you going to have that on your test? No, or quiz. So what goes into, is 750 divisible by 6? Say it again? Maybe. How can we check? Okay, divide it. Come on, write it down on paper. Come on, divide. I know. Oh, so annoying. It is 125. Thank you, sir. So I can take that 6 out here, and I'm left with x cubed minus 125. Is that the difference of perfect squares? Nope, it's a difference of what? Cubes. Good. So your 6x squares out here. Your a term is x. What's your b term? 5, right? What number times itself 3 times gives you? So in this case, we're subtracting. So it's x minus 5. And then on the inside, I have x squared. What's tricky here? Plus, good, 5x plus 25. You are going to get numbers, guys, that are not just going to be like, oh, 12 divided by 2. You're going to have to write it down and do some little work there. So be aware. All right, x cubed plus 4x squared minus x minus 4. Is there a GCF? No, not right off the bat. So if I have 4 terms, what's the magic rule? What do? We're going to group the first 2 and the second 2. Notice I kept that minus sign with that negative x. In my first parenthesis here, guys, what can I take out between x cubed and x squared? X squared, good. When I divide that out, I'm left with x plus 4, correct? What do I want my second parenthesis to look like? X plus 4. Use that as a guide. Right now, it doesn't look like that. But can I take something out of negative x and a negative 4 to give me x plus 4? Negative 1. So I'm left with x plus 4. Now, what is my new GCF that I'm going to write one time out in front? X plus 4. And then what happens with my leftovers? X squared minus 1 gets its own parenthesis. Check. I'm left with 2 terms. One of them is squared, and there's a minus sign. Is that the difference of perfect squares? Yes. What times what is going to give you x squared? X. What times what's going to give you a negative 1? Plus and minus, right? Oops, that's right, the 1. Good job, good job. Let's do the last one. Then one more little thing to talk to you about. You guys are doing awesome. Thank you very much. So 3y cubed plus y squared plus 9y plus 3. GCF? Sure. Not out of all of them. It's tricky. Almost. I have 4 terms, though, so let's group and see if we can figure something out here. What do they have in common? What can I take out? Perfect. Y squared. And then I'm left with 3y plus 1. Okay, so that's what my second parenthesis should look like. Use that as a guide. What can I take out of 9y and 3? Okay, so a positive 3, and I'm left with 3y plus 1. So did this factor nicely? Yeah, my new GCF I'm going to take out right one time is 3y plus 1. And then what happens to my leftovers? They get their own, y squared plus 3. Check. Is what I have left over the difference of perfect squares? No. 3 is not a perfect square, and a plus sign is not the difference. So you are finito there. Good. All right, we're going to talk to you for quickly, and we'll talk about it a little more tomorrow, about the factor theorem. If something is a factor, your remainder is 0. Like 12 divided by 3 is what? 4. Goes in evenly. So 3 and 4 are factors of each other, okay? That's what we're going to talk about right now. They're going to ask you, is something a factor? Are you guys familiar with synthetic division? Okay, good. You've seen that. All right, so let's look at A. Determine if x minus 2 is a factor. So the first thing we're going to do is set x minus 2 equal to 0. When you solve that, what do you get? Positive 2. So I'm going to take 2, I'm going to put up here in my corner, and I'm going to synthetically divide this. How do we synthetically divide? It's the coefficients of all of the variables, right? So what's the coefficient of x squared? 1. What's the coefficient of x? 2. And then what's our constant? Negative 4. If something is a factor, when you synthetically divide, your remainder will be 0. If your remainder is not 0, it's not a factor. That's it. Remember, when you synthetically divide, guys, everything needs to be accounted for. So if you start off with x squared, you need to have a place for x squared, x to the first, and x to the 0, or the constant. So for synthetic division, we bring down the first term. We multiply to the corner. What is 1 times 2? 2. So I'm going to put it here, and then I add down. What's 2 plus 2? 4. Okay, so multiply to the corner. 4 times 2 is 8, and then I add down. What's negative 4 and 8? 4. Is my remainder 0? No. So your answer here would be no, x minus 2 is not a factor. When would my answer be yes? If it was 0. So let's do the same thing for the next one. They want to know if x plus 5 is a factor for the polynomial. Well, what am I going to synthetically divide with? What is x going to equal? Negative 5. That's going to go in my corner. So negative 5. Now I write the coefficients of my polynomial. So I start off with x to the fourth. What's the coefficient of x to the fourth? 3. Then what? 15 for x cubed. What's the coefficient of x squared? Negative 1. What's the coefficient of x? 0. Very good. There isn't one, so I have to have a placeholder. And then what's the constant? 25. If you guys do not have something represented, you have to put a 0. Everybody got that? All right, so let's get our synthetic division party started. Bring down the 3. You always bring down that first term. Then we multiply to the corner. What is 3 times negative 5? Negative 15. Good. Now add down. What's 15 and negative 15? 0. Perfect. Multiply to the corner. What's 0 times negative 5? 0. Now we're going to add down. What's negative 1 and 0? Negative 1. Great. Multiply to the corner. What is negative 1 times negative 5? Perfect. Now we add down. What's 5 and 0? Perfect. Multiply to the corner. What's 5 times negative 5? Negative 25. You're fine. That's fine. Thank you. And then I add down. What's 25 and negative 25? 0. So you guys just did all the math. You proved this. What is the answer to this question? Yes, x plus 5 is a factor. And why is it a factor? Because your remainder is 0. Good. Very good. It's fun, right? All right, let's do the last one. Ask you to do 2 things, and we're done. You're going to show that x plus 3 is a factor, and then factor completely. So there's 2 steps here. What did I tell you at the very beginning we started this? How many answers should I have for this question? 4. The highest exponent tells you how many answers. So the first thing I'm going to do is show that x plus 3 is a factor. So x plus 3 equals 0. What goes in the corner? Negative 3. So one of my factors is negative 3. So let's write out our coefficients. X to the fourth, my coefficient is 1. X to the third, coefficient is 3. What is the coefficient of x squared? 0. Then I have negative 1, then I have negative 3. It might help, guys, if you write yourself a little note. Say, okay, I started off with x to the fourth, so this is x to the third. This is x squared. This is x. This is my constant. That might help. So now let's synthetically divide. If we're showing that this is a factor, what should my remainder be? 0. Okay, multiply to the corner. 1 times negative 3 is negative 3. Add down. 3 and negative 3 is 0. Multiply to the corner. 0 times negative 3 is 0. Now I add. 0 plus 0 is 0. Multiply to the corner. 0 times negative 3 is... All right, to the corner. 0 times negative 3 is 0. Negative 1 and 0 is negative 1. Now, negative 1 times negative 3 is 3. Negative 3 and 3 is 0. So we showed that that was a factor. Now it says to then factor completely. Well, what does that mean? Well, what you have here, guys, is what's called your resulting polynomial. It's what's left over after you divide in here. And it always starts 1 less than what you started with. Since we started with x to the fourth and we divided, this is your x cubed, this is your x squared, this is your x, this is your constant, that's your remainder. So how would you write your resulting polynomial? You would say x cubed minus what? Minus 1. Can you factor that anymore? No. If it was x squared minus 1, yes. But that's not the difference of perfect squares, is it? But wait a second. It's not the difference of perfect squares, but is it the difference of perfect, is it? What times what gives you x cubed? X. What times what gives you 1? This is, guys. So A is 1. Sorry, A is x, B is 1. You are subtracting, correct? So you'd have x minus 1. And then what does the second parenthesis say? First term squared. So x squared, what? Plus, good, 1x. And then plus 1. That's tricky. Always, 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 guys, don't just assume, oh, it's not a perfect square, it doesn't factor. Now, if you guys go to YouTube, please, 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 I'm going to upload this video. Just search my name, Jay Meadows, and I have an Algebra 2 playlist. Don't go to the Algebra 2 Honors one, go to the Algebra 2.